Welcome to Calculus 2. Calculus 2 mostly it is taught to second year student, that is undergraduate student in mathematics, and many students taking science courses including B.Ed Science, Mathematics, including BSc, including engineers. They find themselves learning this subject. So this subject is critical to many students. So today in this Calculus 2, we are considering integration by part. And integration by part work properly when you have two functions which are continuous and differentiable and integrable, continuous and integrable. So we are going to consider function u and v. So this is the formula for integration by part, which is say that when you are given integral of u dv, the answer will be uv minus integral of v du. So here we are going to let dv to be equal to v prime, and we are going to let du to be equal to u prime. So let us jump to an example so that we see how this is done. So we have this example here where you are told to integrate this function x exponential x dx. So what you do, you start by letting, when you are letting, you let your u to be a function which will be easy for you to integrate in this part. So we can let our u to be equal to we let our u to be equal to x, then du over dx will be equal to 1. Then we also let our dv be equal to the remaining part, which is exponential x dx. We are letting this remaining part here, exponential x dx, to be our dv. Then from there now we integrate both signs here. We take integration of this function. So when we integrate and we differentiate v, we are going to get v. When we integrate the exponential, the result will be exponential x. Then from there, we substitute now. We substitute our result in the formula. So integral of x exponential x dx will be given by this formula here. Our u is x. Our v, we have found it to be exponential x minus integral of our u prime, that is du. Our du here with respect to dx is 1 multiplied by our v. Our v is exponential x with respect to dx, now which is equal to x ex minus, when you integrate exponential x, the result will give you exponential x plus some constant c. So that is how we integrate a function by part. That is example 1. I want to give us another example. So we have this other example here, x power 4 ln x dx. So remember our formula is always given by dv, which is equal to u v minus v du. So in this case, we are going to let us let our u to be equal to ln of x. We let our u to be equal to ln of x. Then du dx will give us 1 over x. Then we let our dv be equal to x power 4 dx. Then we integrate both signs. We integrate both signs here. So when we integrate, integrating and differentiating will give you v. V is equal to 1 divided by 5 x power 5 plus c. Then from there now we come and we substitute to our formula. So integral of x power 4 ln of x dx is equal to our u is we have let our u here to be ln of x multiplied by our v is x power 5 divided by 5 minus integral of our v is 1 over 5 x power 5. This one, our v, this is our v. Then our du over dx is 1 over x multiplied by 1 divided by x, which is equal to, this can be written as 1 or ln x multiplied by x power 5 divided by 5 minus 1 over 5 is not affected by the integration, so you can take it outside. Integral of this x here will cancel and we are going to get x power 4 dx. Note here there is dx. There is dx there. Then the next thing, this is equal to x power 5 ln of x divided by 5 minus, when we integrate this we are going to get 1 over 5 divided by 1 over 5 x power 5 plus some constant c, which is equal to x power 5 ln of x over 5 minus 1 over 25. 5 multiplying by that will give you that. Then x power 5 plus c. So that is the result of integral of x power 4 ln of x dx. That is the result. So we look at this example. Always you begin with the formula. So the formula tells you that integral of u dv is equal to uv minus v du. So now you can see it is easier to integrate the exponential x. So you let your u be equal to sin x du will be equal to cos of x. Then you let your dv be equal to exponential x dx. Then you take integral on both sides. Yeah. So when you integrate in dv and differentiate, you are going to get v. Exponential differentiated will give you exponential. Then now you come here and substitute. Your result. You have exponential x sin of x dx is equal to, our u is sin x and our v is exponential x. So you have exponential x sin of x minus into bracket our v is exponential x. Our du, this one, du is cos x dx. So at this stage now, this one, we deal with this again. We let a second stage our u to be equal to cos of x. Our du will give us negative sine of x. Then we let our dv to be equal to exponential x dx. Exponential x dx. Then we take integral of this both signs. We integrate this both signs. When we integrate, and we differentiate, we are going to get v, which is equal to exponential x plus some constant. Then we come and substitute there now. So we write all of it here. We have integral of ex sine of x dx is equal to exponential x sine of x minus, we subtract it now. We are going to employ this formula here. Our u and the v, our u in this case is cos x. Our v is exponential x plus some constant minus, our v is exponential x, our du is negative sine x minus integral of exponential x multiplying by sine x. Sine x that way, which is equal to exponential x sine of x minus exponential x cos of x. Here we have 3 minus, and the minus will give us minus exponential x sine of x dx. There is dx here. Remember that there is dx there. Now, when we look at this part here, exponential x sine x dx is the same as what is in the left hand side. So we can take this the other side. When we take it the other side, it will be an additional. So we are going to have exponential integral of exponential x sine x dx plus integral of exponential x sine x dx is equal to, we have taken this the other side, is equal to exponential x sine of x minus exponential x cos of x. So you can see these are two. We have two integral of exponential x sine of x dx, which is equal to exponential x sine of x minus exponential x cos of x. Now we can divide both sides by 2 to be left with integral of exponential x sine of x dx is equal to half, dividing both sides by 2 of this part here, exponential x sine x minus exponential x cos of x. And now we have answered our question. The question was to integrate integral of exponential x sine x dx. So this is the result which we are going to obtain. So we are going to look at another final example on integration by part. Well, example 4. When you have example like this now, of course we see this is integration by part. The formula, remember the formula, this is the formula. The formula is u dv is equal to uv minus v du. When you have x here, having this part, it is wise for you to use what is called the tabular form. So you are going to use tabular form. It is easy when you use tabular form, like what I'm going to show you below. As we can clearly see here in this formula, the sign you alternate. So the first sign here will be positive. We are going to let our u to be x power 3. Our dv, we are going to let it to be exponential x dx. So what you do now, you differentiate this. You differentiate x cubic. So the first answer will be 3x squared. That is the first result. You integrate this. So we have here integral of exponential x dx. Of course, this is equal to dv. So you integrate in both signs. When you integrate in our v will give you exponential x. So here you write exponential x. You move to, and the sign is alternating, so this is minus. The next one will be positive. 3x squared differentiated will give you 6x. Next, you integrate exponential x, which will give you exponential x. The third distance is you differentiate 6x. The result will be 6. Then exponential x, which will give you exponential x. You continue up to the time you obtain on the u 0. So 0. The next one is exponential x. And you remember now to alternate your signs. So you have plus, minus, plus, minus, plus. So what you do now, when you are writing your answer, when you are writing your result, you have x cubic exponential x dx. Remember our formula, this is our formula. Our u is x cubic, our dv is ex dx. So which is equal to, in the first formula you can see our u is x cubic. The first one will be your u, which is x cubic, multiplied by the v, which is this one. So this is what you are going to have. You multiply this, that one, this other one, and that other one. As you take into consideration the signs. So here we are going to have x cubic exponential x. The second one will be negative 3x squared, negative 3x squared exponential x. The third one is positive, so plus 6x multiplied by exponential x, plus 6x multiplied by exponential x. This one. The other one is minus, so minus 6 exponential x, of course, plus a constant. So you can see when you have a question, like this, it is easier for you when you employ the integration by using a tabular form, and you get your result as shown here. So let us look at another good example. Example 5, you have x squared sine of x dx. So also in this case, it is good if you use the tabular form. Remember the formula is this: u v minus v du. So that is the formula for integration by part. So you can use your table. We are going to use a table like this one here. So in this case, we can let our u to be x squared. The first sign is positive. We let our dv to be sine of x dx. So integrate dv, which is equal to sine of x dx. We integrate both signs. When you integrate, of course, you will get v, which is equal to cos of x plus some constant. So this is minus, because when you differentiate cos, you are going to get negative. So negative and the other negative will give you positive. So integral of sine x is negative cos x. So here we are going to have negative cos x. Then we will differentiate x to give you 2x. This is negative. Next thing is it will be positive, and here you will have 2. When you integrate cos, it will give you negative sine of x. When you integrate side again, it will give you negative and negative, so it will give you positive cos of x. 2 differentiated is 0. Next, now it is to write our result. So remember our formula. Remember our formula here. Our u is x squared. Our dv is sine x dx. So our u is x squared, this one. Our v is minus, so minus cos of x. Then the second one is minus 2x. So you multiply these ones that way. And now you make use of the sign here. So our first one is negative. Because of this negative, x squared times cos squared, that one, minus 2x minus sin x, which will give you plus. Minus and minus will give you plus 2x sine of x. Next one is 2x cos x plus 2 cos of x. So integral of x squared sine of x dx is equal to negative of x squared cos of x plus 2x sine of x plus 2 cos of x. So you can see it is easier when you have x having a power there to use your tabular form, and then to employ this table here to use the tabular form. It becomes easier for you to make use of the methods of integration by part. So thanks so much for your time in learning this video. Kindly remember to like, also to give me a thumb up, and also to click the notification bell so that you will receive videos pertaining Calculus 2 and the other areas of mathematics which I upload every day. Bye bye, and thanks my fellow mathematician for your support. See you in the next video.